Today we're going to discuss how to analyze functions or how to interpret the actual graphs. First thing we're going to discuss are intercepts, which is where graphs hit an axis. Now I have two axes, as we've talked about earlier, one the x-axis and one the y-axis, and thus we're going to have x-intercepts and y-intercepts. In this graph I have 1, 2, 3, 4 x-intercepts, and we'll name them by their points. So -3, 0, -2, 0, -1, 0, and and 1, 0. We only have one y-intercept, that being the point 0, -6. Sometimes functions are referred to as what are called linear functions. In other words, graphs that appear to be perfectly straight lines that also pass a vertical line test. So this is an example of a linear function, straight line, pass a vertical line test. While this passes a vertical line test, making it a function, it undulates up and down, so it's not linear. When we talk about graphs, sometimes we say a graph is positive or a graph is negative. In other words, a graph is positive when its y values are above the x-axis, and it's negative when its y values are below the x-axis. So in this case, I see y values, or the graph being above the x-axis here, and in this region here, and in this region here, and being below the x-axis in this region here, and in this region here. So let's go ahead and state when the graph is positive and negative. And I'm going to jump a little bit ahead and use inequality signs, but I would assume that you've had those in middle school, so let's go ahead and do this. This graph is positive when, and we state when they're positive by stating the x values in which they are above or below that axis. So when x is less than -3, this graph is positive. So where I'm talking about is up in this region, and x is to the left of -3, so x is less than -3. Now in this little hump right here, that hump falls between an x value of -2 and -1. So I say from -2, the value is greater than but less than -1. Likewise, there is a region over here that's above the x-axis, and that is from 1 out forever. So when x is greater than 1. So that describes when the graph is positive. When it's negative is when it's below. And you'll see it's below between an x value of -3 and 2. So I can say it's negative when x is greater than -3 but less than -2. And it's also underneath between values of -1 and 1 for x. So -1 is less than x, which is less than 1. Now, we say the graph increases as it rises from left to right. So let's start way left and put our pencil over here and follow the graph. Well, this graph is falling, so it's decreasing, and it decreases until about this point here. So it decreases. Then from this point up to this point, it increases. From this point down to this trough right here, decreases again, and then for the rest of the graph, it increases. And again, if we want to describe when it increases and decreases, we describe that with its x values. Now we're going to estimate here. I'm going to say this x value is about 2.5. This x value is about 1.5 of the negative type in both cases. This value, let's just say it's 0.5. And we can start describing this now. So this graph is going to increase when x is greater than negative 2.5 and less than negative 1.5. And it also increases when x is greater than 0.5. To tell where this falls, we can say it falls or decreases when x is less than negative 2.5, and then it also falls when x is greater than negative 1.5 but less than 0.5. Alright, the next term we're going to talk about are extremas. I spelled that wrong. It should be E-M-A. So extremas are points where the function reaches a momentary high or low. You'll see this graph goes up forever and down forever, but there are these peaks and valleys within the graph itself. Those peaks and valleys, these points in red, are all known as extrema. We talk about extrema being one of two types. Either relative minimums, in other words, they reach a momentary low value, or I call it a valley sometimes, and a relative maximum is where they reach a relative high point. So these 2 points here are peaks. All right? Now, if we want to name the extrema, we would say there is a relative minimum of roughly a value of negative 3, and we say that happens at negative 1. Notice, this is a y value when we talk about the minimum value, and an x value when we talk about where it happens. We also say there's a relative minimum of negative 1, once again a y value, at 4, and that's our x value. If I want to talk about a relative maximum, these are the peaks, so we say a relative max of 2 is the y value, and that happens at negative 3, once again the y and the x. And then we also have a relative max of 1, and I'm talking about this point up here, at an x value of 2. Next, we'll talk about something called end behavior. And end behavior describes what's happening to y values when x values are either very big positive or very big negative. So when we talk end behavior, we're talking about when x is way out here, what's y doing? And when x is way over here, what's y doing? Now you'll notice the arrows on this graph state that this graph goes up forever from this point on, and this graph goes down forever from this point on. So what I'm going to do is now describe the end behavior for you. So to do that, we say as x grows large, positive, y grows large, positive. Another way to possibly state that, maybe a little more simply, is as x increases, in other words, it's getting bigger, y increases. This is probably a more efficient way to deal with this, but this kind of puts it in more English terms. All right, that's only half of the end behavior. To finish the end behavior, I have to then say as x decreases, so in other words, as x goes down, y decreases. So y is dropping as well. Inside this box here is your end behavior. Sometimes graphs have lines of symmetry, and as stated in this problem here, the line of symmetry is basically a line that divides the function in such a way such that each half of the graph matches the other half. So if I were to take and fold this graph over this yellow line right here, this being my line of symmetry, then the left side of the graph would flip right over to the right side of the graph and match. So now I'm going to take this function and I'm going to describe all the following concepts. So there's quite a bit of them. First thing we're going to do is we're going to name all the intercepts. So let's go ahead and do that. First of all, let's look at my x-intercepts, where it crosses the x-axis. 1, 2, 3, 4, 5 spots. Okay? So we're going to say x-intercepts. That happens at -3, 0, -1, 0. I'm going to say roughly 1.5, 0, 2.5, 0, and let's say 7.80. It's not an exact science sometimes. Y-intercept. Where does this thing hit the y-axis? Well, that hits the y-axis at this point right here, roughly 0, 2. Step 1. We have extrema. Where are my extrema? This appears to be a momentary high. This appears to be a momentary low. This appears to be a momentary high, and this appears to be a momentary low. Now let's discuss what those are, maximum, minimum values. We say we have a relative max of, let's look for our y values. That appears to be at 3, and it happens at an x value of 1. Once again, y values are what the maximum values are, and where they happen are the x values. There's also a relative max of, here's this other relative max here, and it goes all the way up to 8 at the x value of 6. Now let's take a peek at a relative minimum. So if I want my relative minimums, those are my low points. So I have a relative minimum of, the y value appears to be at -1. And that happens when the x value is -2. And then I also have another relative minimum where my y value is -4. And that happens at an x value of +2. Step 2 done. Next, we're going to state where this increases and decreases. So let's go increasing first. Where does this rise as I go from left to right? Well, it appears to rise in this area and this area here. And then it falls in this area here, this area here, and this area here. So we're going to say it increases when x is greater than -2 but less than 1. It also increases when x is greater than 3 and less than 6. Likewise, it decreases or goes down when x is less than -2, when x is greater than 1 but also less than 2, and when x is greater than 6. They all go down. Finally, let's describe the end behavior. So as x increases, so in other words, what I'm talking about is I'm talking about when x goes this way, that's for x increasing. And then when x decreases, I want to know what happens this way. Now this will continue to go in this direction. This will continue to go in this direction. So back to our end behavior. As x increases, it appears that y is going down. Y decreases. And as x decreases, again I'm talking about the left side of the graph, it appears that y is increasing. And thus I've described those 4 things. That's all we've got for you. I've got a number of multiple choice problems I'd like you to take care of and then fill out your lesson summary on the form. So here's your first one. I'll scroll down. Second one. And then finally the third one. And I'll see you tomorrow.